Hi everyone. In this video we are going to see what is ASIC Design Flow. ASIC Design Flow is divided into two parts. One is front end and one is back end. Now we are going to see what are the steps that we are going to follow in the front end verification. First one, specification. Second one, architecture. Third one, IP design. Fourth one, IP verification. Fifth one, SOC design. Sixth one, SOC verification. All these steps will be called as front end verification. In this video, we majorly focus on the first two steps. One is specification and second one is architecture. Let's take an example of phone manufacturing. Imagine a mobile phone company wants to launch a new smartphone next year. Before engineers start designing anything, the company first decides what features the phone should have. Example: 12 GB RAM, 256 GB storage, 5G support, and battery life for at least one full day. All these requirements will be written in a document. This document doesn't explain how to build the phone, it only explains what the phone should be capable of doing it. Let's take a real life analogy. Suppose you are going to a hotel and ordering a pizza. The restaurant cannot start preparing pizza without the requirements. Example: size, crust, toppings, cheese, delivery time, budget. Restaurant cannot start cooking until all these requirements are defined. Let's see the definition of a specification. A specification is a document that defines what the chip must achieve. The specification documents includes performance, power, area, cost, and functionality requirements. Every chip starts with a specification. Just like you tell a pizza shop your requirements before they make a pizza. Similarly, a customer tells the engineers the performance, the power, and the future requirements before a single line of RTL is written. Let's take one more example. Suppose the company wants to design a smartphone SoC. They need to mention all the requirements in the specification. Let's see what are the requirements mentioned in the specification. CPU cores 8, frequency 3 GHz, AA performance 50 trillion operations per second, power less than 5 watts, technology 3 nanometers, cost target $50. All these were made in the specification document. At specification stage, nobody has decided how many prime performance efficiency cores used in the chip, or what is the cache size, or what is the bus architecture they are going to follow, either AHB, APB, or AXI, or number of transistors. This and all not mentioned in the specification. This will be done in the next step called architecture. Now that we have completed the specification phase and clearly understand what the customer wants, next question is how we are going to build it. This is where architecture phase begins. We have seen a previous example of pizza. The customer has already specified a large spicy pizza with extra cheese. This specification tells us what needs to be delivered. The architecture team now creates a plan for how to deliver it. Now the chef thinks, how can I make this pizza in the 20 minutes? He needs to create a plan. Which dough to use, how much cheese, which toppings, which oven, what baking temperature, how many cooks needed. Total this planning is called architecture. We have seen in the specification of smartphone SoC, they have mentioned it as an 8 core. Let's see what is a core. A core is an independent processing unit inside a CPU which can execute instructions and perform tasks. Suppose if a CPU contains a single core, it can able to perform single task at a time. If it contains 8 CPU core, where multiple tasks can run simultaneously. Suppose while you are using a phone, you are watching the YouTube, downloading a file, using WhatsApp, listening to the music. All these operations will be performed by the multiple cores so that different tasks handled simultaneously. So specification team has mentioned total 8 cores. Now it is in the hands of architecture to decide what type of cores he is going to use. Now architecture decides 1 prime core, 3 performance core, and 4 efficiency cores. Let's see one by one. Primary core, the fastest core, handling games, AI, heavy applications. Suppose you are playing a game, so this primary core gets activated. Next one, performance core. Good balance of speed and power. Like when you are video calls or Microsoft Office, this performance core get activated. Efficiency core, low power consumption, background tasks. Suppose you are using a WhatsApp, you are reading a chart. At that time, the efficiency core gets activated. How fast are they? Now, architecture decides the operating frequency. Example, prime core operates at 3.5 GHz, performance core operates at 3.0 GHz, and efficiency core operates at 2.0 GHz. So, if the computer is performing the high performance task, so they are going to use prime core. If it's a medium, then you are going to use performance core. If it's a very less a small task, you are going to use efficiency core. As a high frequency means you need to put a more work on the CPU, so it consumes more power. From this video we came to know that specification means what should the chip do, architecture means how will the chip achieve it. We have used pizza and smartphone analogies to understand specification and architecture. Now it's your turn. Using a house building analogy, explain the difference between specification and architecture in the comments. Thank you for watching this video.